Hello and welcome to part 2 of our momentum question feedback. Sorry for a slight change in scenery. Let's start on with question 2. So, question 2, as you can see in the comments, is that object AB, so again, if we draw a diagram, AB, has a mass of 45 kilograms and no initial velocity. Oops. Almost forgot, we represent initial velocity with a U. It then explodes. Two masses it splits into are objects A and B. A and B. Object A, if we look closely, has a velocity of minus 18 meters per second. Now, it's a minus, so remember what a minus means in terms of velocity. It's not that we've gone in some weird, crazy world where there can be a negative speed. It's all to do with direction. So a really good idea is to always have at the top a plus. The positive is to the right, therefore anything to the left must be negative. Which makes sense if you consider the question. Object B has a mass of 20 kilograms. Now, you have not been given the mass of A, and you have not been given the velocity of B. Part A is to actually find the mass of object A, and part B is to find the velocity of object B. Well, part A should be quite simple. We're remembering that we're conserving mass. So if we've got 45 kilograms to begin with, and object B is 20 kilograms, A must be the remainder, which is, of course, 25 kilograms. So that is part A. Part B, however, requires a little bit more finesse. As you can see, I've run out of space again, so I'm going to be turning over. So we start off, let me just make sure this is lined up, there we go. We start off by doing what we've always done and found the sum initial momentum. If you remember what our symbols mean, sigma, sum of, P is momentums, and I is representative of the initial situation. So this is going to be the mass of AB times the velocity, the initial velocity of AB. Now, this is where a lot of people panic because, if you recall, object AB has no initial velocity, therefore U is 0, therefore the sum initial momentum must also be 0 kilogram meters per second. This is to be expected. 0 velocity means 0 momentum. We are expecting this, so do not panic, this is all to plan. If we continue with that, we also must remember the conservation of momentum, that the sum of the initial momentum always equals the sum final momentum. Therefore, the sum final momentum also equals 0 kilogram meters per second. Again, completely expected. Now, again, I will have to remove my working. You guys should obviously keep your working. Should look quite a lot like this. So make sure you keep hold of it. So we'll just rub that off. And just write a reminder at the top that our sum of our final momentums equals 0 kilogram meters per second from our previous reasoning. So, if we carry on, we can see that the sum final momentum must be equal to the mass of A times the velocity of A plus the mass of B times, running out of space, velocity of B. So that is, again, using the P equals mv equation. We just have mv of object A and mv of object B. Those two objects, if it's a sum momentum, we have to add those together, and therefore we have to calculate them individually. So, again, we might want to put numbers straight in. You can do that if you want, or you can just rearrange the equation and stick the numbers in. That's completely up to you. For a change, I'm going to go with rearranging, because I think it is a valid method. It's a valid physics method. You should rearrange your formulas before you put the numbers in. At GCSE, it's less of a problem. It's all due to significant figures and accuracy, but it's good practice, so we'll go with that. So, if we subtract MBVB, we get, sorry, I'll remove that. That is not what we're meant to do. It's meant to subtract MAVA. I do apologise. So, sum of the total final momentum minus MAVA equals MB VB. We don't have to have the second part in brackets because it's the only expression over there. We've got the MB, so we just need to divide by MB to get an expression. So if we divide by MB on both sides, we get an expression for VB. Now we have all these values, so we might as well just enter them in. So that is 0 minus MA. Well, if we look to our question, MA has a mass from our previous answer of 25 kilograms. So that's 25. And the velocity of A is minus 18. Now this should hopefully give you a bit of a respite because you've got your minus and your minus there. Those minuses will cancel. So we will end up with a positive answer, which is what we're expecting if you look back to the original diagram. Divided by MB, which in the original question is given as 20 kilograms. Let me just get a calculator very briefly. There we go. If we type that into a calculator, we'll go with 25 times minus 18 equals, that gives us minus 450. 0 take away answer equals 450 divided by 20 equals 22.5. So our answer is 22.5 meters per second. So, there's the answers of both of those questions. Join us for part 3, and we will continue with the next question. Please rate. Obviously, I would like to see whether or not these are really helping with GCSEs. Thank you for watching.